Okay, we are diving in again to the respiratory system. If you want to go with me, not respiratory, how about integumentary? Sorry, my brain is very, very toasty this morning. Oh, thank you. I would like to collect those beautiful projects that you made. How about you just come bring them up here? Just come bring them right up on the desk here. All right, are we ready? Have a seat. Shh. Of course your name is on these, right? Or maybe I'll just hold them up and say, okay, who wants this credit? This one? Who wants this? This? Oh, that's a nice one. Yeah? Cool. Excellent. We good? And again, I promise we'll get these back to you shortly. Okay, I won't hang on to them long. Shh. Everyone's we're good? Because as of right now, you're late if I don't have it, right? Sorry, he's putting it together. We're good? Of course, if you put it on Schoology, it's fine. Because again, there's a few of you who did it online, that's great. The vast majority of you were hardcover, hard-backed, physical objects. Okay. Sorry, before I dive into this, I want to sincerely apologize. I am just overwhelmed with stuff to do right now. I know that I have retakes that I have not graded. I know that I have the last chapter test that you took. Those of you who were later after assault, I will get them up, I promise you. Okay, I do have these next 2 days that I'm at a conference. Maybe I shouldn't say this on the recording, but let's just say perhaps that the conference may be boring at times, and perhaps there may be some grading that will be done. Theoretically, possibly. Hopefully not. Hopefully not. But I will bring it with me, that's for sure. Okay, so again, as soon as I get those up, we'll talk about retakes. I've already had a conversation with a couple of you looking up who have already graded that piece for a retake. That's fine. I haven't given you a deadline for that yet. So know it's coming. Let me say this. If, let's say, you didn't do very well on that test that I've already graded, the last one we took, and you are thinking about retaking, I would suggest studying now. Does that make sense? And maybe we could talk about doing that Tuesday or Wednesday next week before your another test coming on Friday, right? Okay, all that being said, yesterday we spent a good bit of time talking about the skin, right? 3 layers. The most deep is what? Subcutaneous layer. What is the most superficial? Epidermis. And what's in the middle? Dermis. The blood vessels are located in every layer except epidermis. Good. Nerve endings are located in every layer except epidermis. Think of the pin, right? And it doesn't hurt, right? It's super thin. Yeah. Okay, it's thick enough to do what it needs to do. And it varies depending on where you are. The palms of your hands, the bottoms of your feet, super thick epidermis. Right? Even has that extra layer, that stratum lucidum or lucidum, I think. Okay? Because again, we're rubbing that all the time, right? We're pushing it here, we're doing things, we're walking on it, etc. Okay? We talked about those 5 layers of the epidermis, right? Where are the epidermal cells actually growing? What layer? The bottom one, yeah. Stratum basale. Yep, the base layer, right? Where are the cells most keratinized? The stratum corneum, the very superficial layer of the epidermis, right? And again, keratin is a protein, right? It means it's harder, it's thicker. Again, it will protect better. We cool? The melanocytes, what do those produce? Melanin. Sure, and melanin gives your skin what? Color. right? Pigment, that's what it is. And again, there's no difference in the amount of melanocytes between a very dark person and a very light person. It's just that the very dark person produces more melanin. As a lighter person spends time in the sun, it produces more melanin to help protect the skin from those UV lights. We cool? And if you spend too much time in the sun, you get burned, and that's a whole other story. We'll talk about that. We got into a little bit yesterday about the nails, and that's where I want to begin today. That the nails are just simply stratified squamous epithelium, just like your epidermis is, but it's been highly keratinized. So it's very thick, very strong. And again, the point of nails is what? Protection. Nail polish. No, nail polish. Come on. No, protection, of course. Protection. It is all about protecting the ends of your fingers. All right. We talked about the fact that nails grow from the bottom up. So the actual cells they're dividing are down here underneath the lanula, underneath this little fold of skin, and they push it up. So again, if you do smash your finger in a door and the nail falls off, because it does happen, okay? It doesn't just immediately grow the whole nail up. It starts from the bottom and grows its way out. And it can take months, depending on how fast your nails grow. Sir? Right, that's exactly right. Because we cut the ends of them, right? And it just grows back. It's the same thing, right? Otherwise, we'd have to, I don't know how we would cut them if they grew, the whole thing in. We have to, scrape them off, with a knife. That'd be kind of weird. Could be fun. If you like to whittle, right? Like whittling your nails. That could be cool. We'll try that on the men's retreat, maybe. That'd be fun. All right, hair follicles. By the way, information for that will be coming out today. Again, overwhelmed. So much to do. The men's retreat. There's a ladies' retreat, too. I'm excited about. This is in 2 weeks. It's coming. No. All right, hair follicles. Let's dive in there. Nearly every place on your entire body has hair. Did you realize this? There are only a very couple of places you don't. Anybody name? This part of your arm? No, there are tiny little hairs there if you look. I don't know. Yes, ma'am. Your eyes, good. That's good. That's a good place.
Wait, your eyes have hair?
Your teeth do not have hair. No. Good. Shh. Sorry? The palm of your hand, that is one place, does not have hair.
Your nails.
Sorry? Shh. So I'm talking about outside, on the skin. Yes. Sure, bottoms of your feet. There's really only one or two more areas. Your lips, like the actual lip pieces, and then the main actual organ pieces of your genitals. There is no hair there. And you're saying, wait, no, there's hair. No, that's just around, not on the actual pieces. So very few places that we don't have hair that is present. Stay with me, guys. Shh. Those individual hairs develop from what we call a hair follicle, which is basically where the epidermis folds down into the dermis. Your textbook uses this term in the lab, or this uses the term invagination, like vagina. That's what it means, is folding inward. Does that make sense? So the skin that comes down around your hair follicle is actually epidermis. It's not dermis. It's this epidermis that has moved down into the dermis to make this little tube. Are you with me? Excuse me. And then again, the hair cells are just like your nail cells. The pieces that are actually growing are down here, right, in this region of cell division. And it pushes the hair upward as it grows. So all of this, like this is about as hairy as you'll ever see me. I'm dying for a haircut and a shave. I just have been too busy. This is dead, right? All of you that you have this lovely long flowing hair, it's dead. It's dead cells. But we make it look pretty, right? Where it's actually growing is down under the skin. And then it pushes it up. Are y'all with me? Cool? All right. There is a muscle that attaches onto these hair follicles called the erector pili muscle. If you look here, it's this guy right here. What does that erector pili muscle do? Muscle contracts, right? It shortens. Why? What does it do when that little muscle contracts? It moves the hair. That's what gives you goosebumps. When that little muscle contracts, it makes that hair stand up straight. Right? Why? Does anybody know why we get goosebumps? Give me raised hands. Lots of conversations. Why do we get these goosebumps? What's the point? Okay, it does help make you warmer. Does anybody know how that works? The hair stands up good. So what does that do for you? It does. It traps a little layer of air close to your skin. And your body heat warms up that layer of hair and actually keeps you warmer. Do you know that's how a sleeping bag works? In a sleeping bag, you have to have space around you to warm you up. So I'm a fairly big guy, right? I bought this sleeping bag that was supposed to be rated to negative 50 degrees. It was this army sleeping bag, dual layer. It was like the stuff, right? And so it was wintertime. I said, I'm going to go out camping. It was maybe 20 degrees. It had snowed a little bit. It's perfect. But I got negative 50, right? I got 70 degrees worth of comfort level, right? I froze my tail off. I was going to stay a couple of days. I came home. I was so cold, right? Why? Well, this sleeping bag was not a long sleeping bag. It was a regular size sleeping bag. And again, I'm a fairly big guy, right? So I was kind of crouched in this bag, and I was right up against the edges of the bag the whole night. Don't laugh at me, Hector. That's tough, man. And because I couldn't trap any air, there was no air being trapped there, I couldn't warm it up, so I froze the whole night. In a different bag that is bigger, like I have this nice big huge down sleeping bag now, that it fluffs up like about this big, and I stay toasty warm in that thing.
I need a new sleeping bag.
Does that make sense? You need space. That's how the goosebumps, that's what they're doing. When those hairs stand up, they trap that little layer of air there and warms it so you stay warmer.
Why do you get goosebumps sometimes when you're like scared?
Sure. So there are other things that will cause goosebumps as well. But that is one thing, is just by helping you keep your temperature regulation. So another thing is some of these psychological pieces, when you're scared, when you're excited, when you're nervous. Anybody get goosebumps when you're nervous? Yeah, no, I do sometimes. Yeah. So there are other things that do cause them. But that is the why. That's a hugely complex question. I'm not sure I can answer that one. Animals. Do animals get goosebumps? Have you ever seen your cat get goosebumps? Like when they're angry or they're going to attack, right? And the hair stands up?
And their backs go like this.
Same kind of thing, right? So it's making the animal appear bigger than it actually is by fluffing out its fur. So perhaps that was something that we got that same piece. Cool. Who knew goosebumps were so exciting? Sir.
What is it like why are the cats like when they get like scared something goes back?
They arch their back again. This is just like an attack position. Yeah, they're ready to pounce. Okay, last piece about hair. The hair color is determined mostly by genetics, and it is from the myelin, not the myelin, gracious, that's in your nerves, from the melanin that is there. So the same kind of pigment that's in your skin that colors your skin is the same pigment that colors your hair. There's actually a couple different types of it. The darker hair has that eumelanin, while the blonde and red hair have pheomelanin. You don't have to know those pieces, but just so you know, there is actually a little different protein between, somebody that has Eric's color hair and somebody that has Hannah's color hair. Are you with me? And of course, you can change that by doing lots of chemical things on your hair, which is cool. Any questions there about hairs? I will mention this. There is a little tiny bit of stem cells. Remember stem cells, undifferentiated cells that are present in the bottom of those hair follicles. So theoretically, maybe someday could they go and harvest those cells and grow you a new arm, maybe? It'd be kind of neat. All right, moving on. Sebaceous glands. Sebaceous glands are a holocrine gland. Remember you had our 3 types of glands? 3 types of our exocrine glands, right? Do you remember what holocrine glands do? Like what differentiates them from merocrine and apocrine? I'd have you look in your books, but they're up on my desk, right? The merocrine glands are just secreting something, right? So they're just giving off fluids. That'd be like your salivary glands, right? The apocrine glands, actually a piece of the cell comes off. So breast milk was the example that was given in your textbook and in the picture. That breast milk actually contains some cells. Did you realize that? It's one of the ways it helps to transfer immunity to the baby. And then holocrine glands, these are actually glands that the cells totally die. Have you heard of a holocaust? Right? Killing of a whole bunch of people. Holocrine glands means I've killed the cells, and that's how they secrete their stuff. And so sebaceous glands secrete what we call sebum. That's why they have their name, sebaceous, sebum, same root. And that provides the oil, in quotes, that is on your hair. And what that does is it moisturizes and it protects the shaft of the hair. Because again, this is all dead tissue, right? So we want to have a way to make it last so you can look pretty. Are we cool? Mm-hmm. So actually the actual hair follicle cells up here, they're dying. Right. And so therefore they can't produce any more hair and you get bald spots. Yeah. And that's completely just a genetic thing. And it's dealing with your mom. Your mom is who passes that on to you. Yep. So you look at her family, look at her father. That's how you have an idea of whether you will have the baldness or not. Okay? So those sebaceous glands are producing that oil. If you look back at the actual picture here, stay with me guys. Can you see that here is that sebaceous gland? Right? There's one on each side here they're showing in this picture. And so they're secreting that sebum right into this area here, which makes sense, right? The hair's about ready to come out of the skin, so let's start getting that protection, getting that oil, get those pieces on there to make it work. We cool? Good. After sebaceous glands, we have another gland that's present here called the sweat gland, right? And you've got 2 different kinds of sweat glands. You've got the eccrine sweat glands and the apocrine sweat glands. The ecrines are what respond to body temperature. You get hot, whew, you start sweating, right? And that's what a lot of the sweat glands that we deal with in our body are, these eccrine sweat glands. The apocrine sweat glands are also responding to temperature, but they also deal with some of these other psychological pieces, like stress. If you're stressed, you start sweating. You know, certainly underarms is where you see it the most. And there is also some sweating that can also become from sexual arousal. Again, these are more like mind type things, the psychological type pieces that will affect those apocrine sweat glands. Are you with me? Sir, Adam, please. Sebaceous glands? Mm-hmm. Sure. So I was going to come back to that piece, but we'll grab it. That's fine. So, are you comfortable that there's a little hole in the skin right up here where the hair comes out? We cool with that? And again, these sebaceous glands are secreting that sebum, secreting that oil to coat that hair, right? So anything that's open to the outside, bacteria can get into it, right? And certainly if there's a time in life, say, where those sebaceous glands start acting more, like producing more sebum, i.e. like when you hit puberty, right? So therefore, if you have bacteria, you have an over amount of oil, that's when we get acne. Does that make sense?
Technically, acne only comes where
Usually. There's some sort of opening, some sort of pore opening. You can also get it in the sweat gland openings, but normally it is around a hair. Yeah. And again, think of, and again, I'm not trying to gross you out, but like the bad thing about having facial hair is that you get these little ingrown hairs, and I'm sure ladies, you get them on your legs too, right? And that's like you get this big, I don't know, it's fun to like pop those little guys. Shoots all over the mirror. Oh, it's good stuff. Yeah. No, it's gross, right? It's gross. But you deal with it, right? And again, those are normally happening because of those sebaceous glands producing that oil.
So basically, just want to know that wherever there's an opening, there's bacteria, oil, and create that.
Yes, ma'am. There is a piece in your textbook that talked about acne. Can you find that for me? There's only one of those little yellow boxes that talked about it.
page 134.
134, you just beat me there. Nicely done. Yes, one of the yellow boxes. Overactive or inflamed glands are producing those small red elevations that are pimples. Yeah, they do, right. Very medically. It's life. You will grow out of it, I swear. Did you know that your ears sweat? The inside of your ears, they sweat. Right, we just call it a different kind of secretion. We don't call it sweat. These are these ceruminous glands that produce this ear wax. So that wax is actually sweat. It's just it's a specialized sweat gland. Did you realize that breast milk is actually sweat? Ew. But it's not the same sweat. It's a modified sweat gland. It's a specialized gland, these mammary glands, that produce the milk. Nasty. Oh, but it's good. We need it. It's good. Please.
What makes it the same as sweat?
What I'm saying is that the gland structure is very similar. So that's why they're categorizing it as a sweat gland, but it's modified, it's specialized. So you're not actually sweating, but it's the same kind of gland. Okay? I just like to talk about that because it gives everybody to, wait, what? Are you with me, friends? Please.
When does breast milk stop?
So breast milk will start very close to when the baby is born, usually even after it's born. It's all hormonally balanced. So after the baby is born, and actually my wife talked about that being one of the most frustrating things was neither of my children quickly wanted to breastfeed. Like it was difficult to get them to do it. And she's like, oh, I'm just a terrible mother because they can't breastfeed, you know? But it's life. That's just, it happens more than you think. So don't freak out, ladies, if, again, you have a hard time getting that breastfeeding going. Then what controls it is how long do they keep going. If the baby keeps coming to the breast and getting milk, your body will keep producing it. That's why you can have people that, it's crazy, but kids that are 7, 8 years old who are still breastfeeding. The mother will keep producing it as long as they keep breastfeeding. There's some my wife always said, if my child can ask for it, I think it's time for them to be done. Does that make sense? There is no right or wrong as far as how long you should go, but it does seem a little bit strange. Shh.
Like when a kid's breastfeeding, if they're sick, then the breast milk.
Sure, well certainly the first bit of breast milk that is produced has tons of antibodies in it. Because of course the baby realized, and we'll talk much more about this, but the baby has no experience with any germs other than what were in the mother already. But now it's traveled through this vagina that is a very germ-y area, because it's open to the outside, right? And now they're in a world where everything that comes is a brand new thing attacking them. So the breast milk is designed to quickly give them a lot of antibodies. I can't say I know for sure if it significantly changes once the baby is outside. I've not read that or seen that. It certainly could happen. They are still getting antibodies from the mother, certainly. And usually what the baby's exposed to, the mother's been exposed to as well. Does that make sense? So I could see there being a connection there. Yeah. All these things you never knew about breast milk, huh? Exciting. Exciting. Okay, so we finished the accessory structures. I want to make sure you see where we are here. We finished all the accessory structures, right? I mean, so I'm sure you can see that we're nearly completed as far as this conversating about this unit goes. We're going to talk about body temperature. We're going to talk about wound healing. We'll talk about burns and cancer. And this page 140 is a very important piece. Obviously, we won't talk about all these things today, but yes.
So what all do you want us to know about like earwax and earring glands?
Again, it's just that they are specialized sweat glands. Yeah. And again, why do we have earwax? Right, to keep things from coming in. That's why we clean them out with those Q-tips, right? Because it catches all the dirt or the bacteria or whatnot, and we want to get rid of that stuff. Well, okay, you shouldn't shove the Q-tip all the way into your ear so it comes out the other side. That's a problem. But no, you can clean the outside. That's okay. Some people use that. There's liquid you can kind of pour. Yeah, I can't. I don't think it's peroxide. It's a different type of earwax stuff. But yeah, I'm not a big fan of that. It hurts my eardrums, so I'm a Q-tipper. All right, let's talk about. In these 10 minutes we have left, let's talk about how your body regulates temperature. Yes, ma'am. It can grow back. It can grow back because it is just an epithelial tissue. Depending on how bad it is, though, if you do rupture it too badly, it could be a permanent damage. But yes, often it will grow back. Your hearing may come back. It may not. It just depends. We'll talk much more about this when we talk about the ears. Of course, you have the other ear. But that eardrum, that tympanic membrane, is what really starts the whole process of you hearing. So if that can't vibrate, you have some troubles. Yeah. Okay, sir.
In reference to the dermis, you said you want to know the dermis, papilla,
Right.
the blood spot, and then the nerves. What do you want us to know about the nerves? Just that the dermis?
Right. Mm-hmm.
And not any of the other, like, or it's not.
Right. Not up in the epidermis. It is in the subcutaneous. All right. Let's continue on here. We're not going to finish this whole piece, but we'll at least begin it. Are you comfortable that keeping our temperature regulated is a huge thing that your skin does? Your integumentary system is so, like, all day long, that's what it's doing, is regulating your temperature, right? And how does it do that? Well, if you're cold and you need to get hotter, what kind of things happen? Give me raised hands. Give me raised hands, because lots of things. Yes, sir? You shiver. So that's actually your muscles contracting, and those contractions cause heat to be released. Are you with me? So that warms you up. Good. What else, sir? You goosebump, right? You get those little, does anybody call it other than goosebumps? There's other names for it. I'm just curious if somebody else had another name you used. Goose flesh. Yeah, there's lots of different names for it. Anyway, and again, we talked about that as being capturing that layer of air, right? Good. What else happens to help you stay warm? If you're cold and you want to get warm, what else happens? Sure, that's that shivering piece. Yeah, definitely. What about in the skin? When you are cold, what happens? Really white. Okay. Why does it turn white? Ooh. Lots of folks want to tell you. Yes.
Because the blood drops down to protect the deeper layers.
Sure. So the blood moves away from the surface down toward the pieces that actually matter. Your brain, your heart, your core, right? Because I can, if I have frostbite and I have to lose a finger, I'm not going to die, right? But if I get so cold that my heart tissue starts dying, that would be a problem, right? So your body's going to protect. So you will have the blood vessels constrict, get smaller, and send the blood toward the core where it's warmer. Does that make sense? So in us lighter skinned folks, we see that as us getting whiter. Okay? Sure. Again, this is another just response of the body to that coldness. Like when your cheeks are nice and red. Sure, the same kind of piece.
So the blood goes to your cheeks?
So, like if you take a cold pack or an ice cube and put it on your arm, you will get this red response, this vasodilation response. Is one of those immediate things, that then will go away. Does that make sense? If the body keeps being cold and cold keeps being applied to that area, the blood will move away from it. But you do have this initial response of blood coming to the area as well. And we don't want that because if blood is on the surface, that heat can move away from it, right? We want to keep it in your body. It's a good question. I don't have a why to that one. I don't. And again, excessive cooling, the only piece you guys didn't mention was inactivating the sweat glands. It'll turn off your sweat glands if you're cold, right? Because we don't want to sweat. Sweating causes evaporative cooling, right? As your sweat evaporates, it takes heat from you. And we don't want that. We want to keep your heat there. Well, again, those are normally more like a psychological piece. But yeah. And again, your body sometimes just does weird things. It almost gets confused in its ways. Okay? I'm going to stop because we've only got a couple of minutes and I have to give you some instructions for while I'm gone. So let me stop this guy here.